Okay, today we'll start complex number in trigonometry. First of all, what is complex number? A number of the form a plus ib is called a complex number when a and b are real numbers and I equals to square root over minus 1. And the I equals to I is the imaginary number here, and in a plus ib this whole indicates complex number. There are two parts, one is real part and other is imaginary part. Real part A and imaginary part is B, and I is the complex number, and this whole I is the imaginary number, and A plus IB whole indicates complex number. We call A is real part and B is the imaginary part of the complex number A plus IB. It's sometimes it's denoted by Z. That means Z equals to A plus IB. If we take Z equals to A minus IB, then it will be conjugate complex number. Z equals to X minus IY. That means if we replace plus with minus, then it will indicate conjugate complex number. Now in Argand diagram, we can represent complex number, real part along x-axis and imaginary part along y-axis. Then in real part, the value is x, and in the imaginary part, value is y. Then this point x comma y will be the Cartesian point, but x plus iy is the total complex number. X plus iy total make a complex number. So this is the representation of Argand diagram of a complex number. If we take addition of a complex number, then we get another complex number. Suppose a plus ib is any first complex number and c plus id is the second complex number. Then if we take the addition, then we get another complex number. So addition and subtraction will get another complex number. Then subtraction also, if we first complex number minus second complex number, then we get another complex number. That means the result will also be a complex number. In division also, in division we get also, if we divide first complex number with second complex number, then we get another complex number. Remember that this I, powers of I is the imaginary number. Imaginary number equals to I equals to square root over minus 1. If we take square on both sides, I square equals to minus 1. Remember it, we have to use in different examples this I square equals to minus 1. So if we take multiplication of two complex number, then we get another complex number. Just multiplication and using I square equals to minus 1, then AC minus BD plus AD plus BC into I. That means A plus IB look like A plus IB. This is why it is also another complex number. So if we take multiplication of two complex number, then we will get another complex number with their result. Similarly, division also indicates, if we divide any two complex numbers, then the result will be also a complex number. Suppose A plus IB and C plus ID, there are two complex number. Then if we divide A plus IB with C plus ID, then we get the result here, just division C plus ID here. But to make A plus B into A minus B formula, C minus ID, we have taken C minus ID in numerator and denominator. Then in value A square minus B square formula. A square minus B square formula, what? This C square plus D square. That means this is also another complex number. That means if we divide any complex number with another complex number, then the result will be a complex number. There are more examples for you in this sheet. Suppose example 8. If A equals to cos theta plus I sin theta, prove that 1 plus A square equals to this. Just given that A equals to cos theta plus I sin theta. Now left hand side, we have to prove this and equals to this. just putting a equals to cos theta plus I sin theta in left hand side, we get this 1 plus a square. Then making this square a plus b whole square formula, a square plus twice ab minus b square. Then just arranging, we get the required result. And now example 10, if a square plus b square plus c square equal to 1 and b plus ic equals to this, we have to prove this condition. A plus ib divided by 1 plus c equal to 1 plus iz divided by 1 minus iz. We are given two conditions, then we have to prove this condition. From the given conditions, b plus ic equals to 1 plus az. But from here, z equals to b plus ic divided by 1 plus a. Just we have found the value. Now by component to divide and do, you must know component do in numerator z, but in denominator 1, z by 1. We can tell is single z by 1. Then we can 1 plus z component do divided by 1 minus z, that means divide and do. From here 1 plus, now putting the value of z, just value of z what, b plus ic 1 plus a, b plus ic 1 plus a, and 1 minus I into b plus c 1 plus a. Just putting these values, and after taking LCM, we get 1 plus a plus ib minus c 1 plus a minus ib plus c. Then to make I free in denominator, we are making a formula a square minus b square formula. A means what, 1 plus a plus c, and b means ib. Then 1 plus a plus c minus ib here, but we have taken plus ib in both numerator and denominator. Just multiplying with this, we get a plus b into a minus b, a square minus b square. Ib whole square means what, only single b square, because I square equals to minus 1. So minus minus cancel, only plus b square. Then in numerator, we get 1 plus a plus ib whole square minus c square. This just a plus b, a minus b formula. Now a plus b plus c whole square. This is another formula, a plus b plus c whole square, 3-term whole square. Sum of 3-term whole square, a square plus b square plus c square plus twice ab plus twice bc plus twice ca. Formula we know. Then minus c square. Then in denominator also, a plus b plus c whole square, a square plus b square plus c square plus twice ab plus twice bc plus twice ca. Then plus b square. Just putting the formula of sum of 3 terms square. Then arranging, putting the value of a square plus b square plus c square equal to 1. This is given condition for us. Then this result gives our left hand side, just left hand side. Actually, we started from right hand side. Right hand side means 1 plus iz divided by 1 minus iz. That means right hand side equals to left hand side. This is why our result is proved. Understand? Okay, from this example, if z equals to cos theta plus I sin theta, prove that first a 2 divided by 1 plus z equals to 1 minus I tan theta by 2. Then in number b, 1 plus z divided by 1 minus z equals to I cot theta by 2. First, here we are given z equals to cos theta plus I sin theta. This is the given condition. And from a left hand side, this is the left hand side, 2 divided by 1 plus z equals to cos theta plus I sin theta. Then equals to, this equals to 2 divided by, we can arrange this 1 plus cos theta plus I sin theta. Just to make a plus b into a minus b, we are multiplying both in both numerator and denominator with 1 plus cos theta minus I sin theta. Okay. Then 1 plus cos theta minus I sin theta. Taking this extra, we can, if you want, we can cancel this. Then you get our previous line. Now in denominator, a plus b into a minus b, a square minus b square. But I sin theta whole square means what? I square sin theta square, sin square theta. But I square equals to minus 1. This is why minus minus plus sin square theta. Now in numerator, 2 into 1 plus cos theta minus I sin theta divided by 2 1 plus cos theta whole square plus plus sin square theta whole square means sin square theta plus cos square theta cut after putting a plus b whole square formula. Then we get only 2 into 1 plus cos theta. 2 cancel. Then we get 1 plus cos theta divided by 1 plus cos theta minus I sin theta divided by 1 plus cos theta. That means just making two part, dividing by 1 plus cos theta. First term divided by this, second term this by this. Then we get this result. Now 1 minus I sin theta. Sin theta, we have to make another formula in trigonometry. Sin twice a formula. Sin 2 into theta by 2. That means sin twice a. Sin twice a means what? 2 sin a cos a. And in denominator 1 plus cos 2 theta formula. 1 plus cos 2 into theta by 2. Exactly. So 1 plus cos twice a formula. The 2 cos square a. Then after cutting one cos here from up and another cos from down, then we get I tan theta by 2. 1 minus I tan theta, which is required left hand side, right hand side. We can put this a plus b whole square formula, a square plus 2a plus b square, then sin square theta cos square theta cut, cancel, then we get this. Just putting this one. From second condition, one left hand side, 1 plus z divided by 1 minus z, just putting the value of z, cos theta plus I sin theta, making a plus b into a minus b formula. We have already done here, but 1 plus cos theta plus I sin theta and 1 minus cos theta minus I sin theta. We can apply the formula 1 plus cos twice a. 1 plus cos twice a formula, what? 2 cos square a. A means what? Theta by 2. Plus, this is also another formula, sin twice a formula, 2 sin a cos a. A means what? Theta by 2. Then in 1 minus cos 2 theta formula, what? 2 sin square theta by 2. That means 1 minus cos 2a formula, 2 sin square a. A means what? Theta by 2. Minus I sin twice a. Sin twice a formula, what? 2 sin theta by 2 cos theta by 2. That means a means what? Theta by 2 only. Then we can take common here 2 cos theta, and in down 2 cos theta, also 2 sin theta, sorry, so sin theta. Then we can take it cos by sin, what? Cot. Then this cos theta plus I sin theta and cos theta minus I cos theta by 2. Now this equals to, we can write, just putting to get a formula a plus b into a minus b, we multiplied sin theta by 2 plus I sin theta 2 on both numerator and denominator. Then a plus b, a minus b, a square minus b square. This is cancelled. I square cos square theta means plus. I square means minus 1. This is why this make plus, and this is also cancelled by 1 formula. Sin square theta plus cos square theta equals to 1. Then in above we get I equals to I into cos square theta by 2 plus sin square theta by 2 divided by cos theta plus cos square theta plus sin square theta by 2. This equals to this cancel, then only I. That means I cot theta by 2. Just simplifying this, we get I here. Just simplifying this part, we get only I. This way I cot theta by 2 equals to right hand side. This way left hand side equals to right hand side. Clear? Modulus and argument. We already know that x plus iy is a complex number, or a plus ib, any form. This types of form called complex number. Now putting x equals to r cos theta and y equals to r sin theta. From this Argand diagram, just putting along x-axis, x equals to, that means real part, and this is the along y-axis, we will get y value, that means imaginary part. After putting x and y, we get this point x comma y. This point P represents this complex number x plus iy. This is the Argand diagram of this complex number. Now we can put from this, if we join OP, then we get this length r. This length r. Then this length OP makes theta angle along x-axis, right? This is why we can write x equals to r cos theta and y equals to r sin theta. Just squaring both equation, then adding, we get r equals to square root over x square plus y square. This r is called modulus, or absolute value of the complex number. Understand? These are what? This R is called modulus or absolute value of the complex number. And now putting this R, we get cos theta equals to x divided by square root over cos x square plus y square, and sin theta equals to this. Now sin theta by cos theta equals to tan theta. Then tan inverse y by x. Angle equals to what will be? Tan inverse y by x. Tan inverse y by x is called argument. Understand? Theta, this angle theta is called arguments or amplitudes Just dividing this one with this, we get tan theta equals to y by x. Tan theta equals to what? Y by x. Then theta equals to tan inverse y by x. Tan theta equals to what will be? Theta equals to tan inverse y by x. This theta is called argument or amplitudes of that complex number and denoted by argument of x plus I1. Understand? So we have to define modulus and arguments with like this. For different angle, we get principal value this. For angle this, we get principal value theta. For angle more than 90 degree, we get principal value this. Just subtracting from this. Another, in third quadrant, for this angle, we get this angle, just opposite one. That means for different kinds of angle, we get the principal value theta. Now from example 13, find the modulus and principal arguments of the complex number. How will get the modulus and principal arguments of this complex number? Now the given complex number can be written as 1 plus 2i divided by 1 minus I whole square. This equals to 1 plus twice i. 1 minus I whole square means a minus b whole square formula square minus 2ab plus b square formula. Just putting this, we get 1 plus I twice divided by 1 minus twice i. That means 1. This 1 is a real number, but every real number can be represented as some real number can be represented as complex number, but every complex number cannot be represented as real number. That means every real number can be represented as complex number. Remember it. That means 1 plus 1 can be represented by a complex number like this. 1 plus 0 into I. 1 plus 0 into I. This is complex form of 1. This is the complex number now. But only single 1 is complex number? Not at all. So this 1 can be represented as 1 plus 0i. So this 1 plus 0i is a complex number. So this argument means what? Modulus means what? This modulus means what? R, value of R. That means absolute value of this complex number is equals to absolute value of this 1 plus 0i. That means absolute value means what? R equals to what? X square plus y square. X means 1 whole square plus y means what? Imaginary part what? 0. This is why only 1. This is the modulus of the given complex number. Now principal arguments of this equals to principal arguments of this complex number, because we simplified it to get this a simple complex number 1 plus 0 into I. And this is why we already know that angle equals to what is theta equals to tan inverse y by x, right? Tan inverse y by x. Y here, what's the value of y? Imaginary part what? 0. And real part what? 1. That means tan inverse y by x. Tan inverse 0 by 1. That means tan inverse 0 only. Tan inverse 0, how many degree? Only 0 degree. Only 0 degree gives the principal argument of the given complex number. Hence modulus equals to 1 and principal argument is 0. Hello. Note down a question, please. Every real number can be represented as a complex number, but every complex number can never be represented as real number. Note down this and you have to explain it. Every real number can be represented as a complex number, but every complex number can never be represented as a real number. Similarly, from example 14, we can find out the modulus and argument. modulus and principal arguments of that complex number 1 plus cos alpha sin alpha. Let 1 plus cos alpha plus I sin alpha equal to r into cos theta plus I sin theta. Just considering equating real and imaginary part on both sides, we get real part here 1 plus cos alpha, 1 plus cos alpha, and only here and right hand side r cos theta, and here imaginary part what only sin alpha left hand side, and in right hand side what r sin theta is the imaginary part. Now first part, first real part, equating real part is 1, equation 1, and second is 2. Now squaring on both equation, then adding, we get r square bracket cos square theta plus sin square theta equals to 1 plus cos alpha whole square plus sin alpha whole square. Then a plus b whole square formula, a square plus 2 is ab plus b square plus sin square alpha. Then we get r equals to what? 2 sin alpha by 2 only. We get these are represent what? Modulus. Now from equation 1 cos theta equals to 1 plus cos alpha by r, then 1 plus cos alpha means what? Cos twice a formula what? 2 cos square a minus 1. Remember it. Cos twice a formula. You have to put here cos twice a. A means what? Alpha by 2. A means what? Alpha by 2. That means cos 2 into alpha by 2 formula. Cos twice a formula 2 cos square a minus 1. Then r, this value are already evaluated, 2 cos alpha by 2. Now 1 cancel, then only cos alpha by 2. From equation 2 sin theta equals to sin alpha by r, then sin twice a formula what? 2 sin a cos a. 2 sin a cos a, then cos cancel, only sin value. 2 also cancel. Now from 3 and 5 we get the arguments, just dividing 4 by 3, then we get tan theta. Tan theta equals to what? Tan theta equals to sin alpha divided by 1 plus cos alpha. Tan inverse theta angle equals to arguments, angle equals to tan inverse y by x. Y by x. Tan inverse y value sin alpha and x value what? 1 plus cos alpha. Tan inverse this sin twice a formula 2 sin a cos a. A means what? Alpha by 2. Remember it. And in similar case 1 plus cos alpha, 1 plus cos twice a formula what? 2 into alpha by 2 cos. Cos 2 into alpha by 2, that means cos alpha. It can be written 2 cos square alpha by 2 minus 1. Cos twice a formula 2 cos square a minus 1. Then after cutting and 1 cancel, 2 cancel from up and down, then cos cancel, only tan inverse tan alpha by 2. Tan cancel from inverse of trigonometry laws, then we get only alpha by 2. So the arguments can be written as these arguments, tan theta equals to what? Alpha by, only angle equals to alpha by 2. This angle can be written as 2 and 5 plus alpha by 2, or 2 k pi alpha by 2. That means this theta equals to alpha by 2 satisfies both equation 1 and 2. So argument of this equals to alpha by 2, and modulus of this equals to r. This r equals to this. This is our desired equation. Okay. From second sheet, we have to prove question number 2. Prove that 1 plus cos pi, phi, this symbol phi pi, 1 plus cos pi plus I sin pi whole to the power n equals to this, plus this equals to this. We have to prove this condition. Now left hand side 1 plus cos pi plus I sin pi, that means first part of the left hand side. 1 plus cos pi plus I sin pi phi. Pi means what? Only pi, another one, but phi this one. 1 plus cos pi plus I sin pi whole to the power n equals to 1 plus cos twice a formula what? 2 cos square a. A means what? Pi by 2. Plus this we have to make it sin twice a. How? Sin 2 into pi by 2. Sin twice a means what? 2 sin a cos a. A means what? Pi by 2. Then taking common in 2 to the power n cos n pi by 2 will be common from this. Then inside the bracket cos pi by 2 plus I sin pi by 2 whole to the power n. Now 2 to the power n cos to the power n 2 1 by pi by 2 only. This can be written as by de Moivre's theorem. This is the application of de Moivre's theorem. Just power multiplying, we get this one, power multiplication, n pi by 2 plus I sin pi n pi by 2. Similarly, this 1 plus cos pi minus I sin pi, what will be? Only this minus 1, this minus 2 to the power n cos n pi by 2, this exactly, but in replace of plus we get only minus 1. This way, this equals to this. Now this taking this sum, it's just taking addition, then we get 2 to the power n cos n to the power pi by 2, 2 cos n pi by 2 equals to this one, right hand side. Just applying just only de Moivre's theorem. Now we'll study de Moivre's theorem statement, important theorem in trigonometry and complex number. Now the statement, for all rational values of n, cos n theta plus sin n theta is a value of this. That means this equals to this. Cos n theta plus I sin n theta is a value of cos theta plus sin I theta whole to the power n. That means what? This equals to this. When written more fully, the theorem states that for all integral values of n, positive or negative, n may be positive or negative, then cos n theta plus sin n theta equals to cos theta plus I sin theta whole n, power n. And for all fractional value of n, if we consider n other than positive or negative, fractional value integer, fractional value means what? Rational, maybe rational or fraction. There are two types of fraction. One is proper fraction and improper fraction. Maybe value of n positive or negative. One value of this cos theta plus I sin whole to the power n is this. That means this equals to this. Cos theta plus I sin theta whole to the power n equal to cos n theta plus I sin n theta. Now for the first case, we will prove this statement, de Moivre's theorem. It has variety of application, especially in electric engineering. It has a vast application, and in Fourier series also, and in Laplace transformation, it has application, de Moivre's theorem. We have to use this theorem, and after using this theorem, we can solve different kinds of complex form in complex number, especially in complex number in Fourier series. Okay, now for the first case, we can consider n as a positive integer. We can consider n as a positive integer, just taking n as a positive integer. By the actual multiplication, let us consider two complex number only, cos theta 1 plus I sin theta 1 and cos theta 2 plus I sin theta 2. Here actually I cannot be seen. You have to put I. Cos theta 1 plus I sin theta 1, cos theta 2 plus I sin theta 2. Okay. Now this equals to just multiplication. Taking multiplication, we get cos theta 1, cos theta 2 minus sin theta 1, sin theta 2 plus I common. Then cos theta 1, sin theta 2 plus sin theta 1, cos theta 2. Then we can write this one, cos A cos B minus sin A sin B. Formula what? From trigonometry, you know, cos A cos B minus sin A sin B, cos A plus B, right? Cos A cos B minus sin A sin B. Formula what? Cos A plus B, then plus I, then this cos A sin B, sin A cos B. Then means what? Sin A cos B plus sin A cos B plus cos A sin B, sin A plus B formula. This is this whole sin A plus B formula. That means multiplying just two complex number for theta equals n equals to 1 and n equals to 2, just considering n is a positive, first complex number for n equals to 1, second complex number n equals to 2, then multiplying we get cos theta 1 plus theta 2 I sin theta 1 plus theta 2. Similarly, cos theta 1 plus I sin theta 2, cos theta 2 plus I sin theta 2, cos theta 3 plus I sin theta 3, we get this one, right? Multiplicate this two multiplication, what? This one, cos theta 1 plus I sin theta 2 plus I sin theta 1 plus theta 2. That means third one complex number, cos theta. Similarly, after multiplication, this will give the result similar like this. Then cos, just adding angle for cos and adding angle for sin. Now proceeding in this way up to n factors. First complex number n equals to 2, n equals to 1. Second complex number n equals to 2. In this way, after many complex numbers, after putting n equals to n, then cos theta n plus I sin theta n. This whole multiplication will be what? Just cos theta 1 plus theta 2 plus dot dot theta n, and I sin theta 1 plus theta 2 plus theta plus dot dot theta n. This is equation number 1. That means just adding angle for cos and adding angle for sine. Now if we consider all angles are equal, theta equals to theta 1 equals to theta 2 equals to theta 3, that means similar angle for theta n equals to, then how many theta will be here? n times theta here. Now cos theta plus I sin theta whole to the power n equals to cos n theta plus I sin n theta. Actually this theta 1 cos theta 1 plus I sin theta 1 means what? Cos theta plus I sin theta. This also cos theta plus I sin theta plus dot dot cos theta plus I sin theta. How many cos theta plus I sin theta? n times. N times means what? Cos theta plus I sin theta whole to the power n. This equals to what will be? Theta plus theta plus theta plus theta. How many theta? N theta. This n theta. And I sin. How many theta here also? Theta plus theta plus theta. How many theta? N theta. This is why for first case n equals to, and if we consider n is positive integer, then cos theta plus I sin theta whole to the power n equals to cos n theta plus I sin n theta. Understand? Now for case 2, when n is negative integer, if we take n as a negative integer, then what will be the statement of the theorem? Let n equals to minus m. Suppose we have to input n equals to minus m, where m is positive integer, then we have cos theta plus I sin theta whole to the power n equals to what? Cos theta plus I sin theta whole to the power minus m. Just putting n equals to minus m in first case. Now this can be written as 1 divided by cos theta plus I sin theta whole to the power m. This equals to 1 divided by, just by case 1 cos m theta plus I sin m theta, right? Just m multiplied with angle from case 1, this one. Now to make this a plus b into a minus b formula, we have to put numerator and denominator cos m theta minus I sin m theta in up and down. Okay, now this is a formula, a plus b into a minus b, a square minus b square formula, a square minus b square formula, cos square m theta minus I square means what? 1. That means sin square m theta. I square equals to minus 1, this square sin square theta plus cos square theta equals to 1. So this value only 1. In up we get cos m theta minus I sin m theta. Now m equals to, in bracket, just minus m, since minus sin minus theta equals to minus sin theta, right? This minus putting in angle side, minus m. This minus m what? This minus m n, minus n equals to minus m we considered earlier. This is why just minus m replacing with n, cos n theta plus I sin theta. That means cos theta plus I sin theta whole to the power n equals to cos n theta plus I sin n theta. For both case, we prove that cos theta plus I sin theta whole to the power n equals to cos n theta plus I sin n theta. Now for third case, if n is fraction, positive or negative, fraction means numerator denominator types number. Let n by pq, p by q, or rational numbers, p by q, where p is any integer or positive or negative and q is a positive integer, then we get cos theta by q plus I sin theta by q whole to the power q equals to, by case 1 we can write theta by q multiply q and theta by q multiply q, just cos theta plus I sin theta, where q is a positive integer. Now taking qth root on both sides, qth root on both sides, if we take qth root here, then this q 1 by q cut, that means this will be is the value of this, right? One cos theta plus I sin theta whole to the power 1 by q, this one 1 by q. Now the raising each of these quantities to the pth power, we have one of the values pth power, taking power p on both sides. Cos theta plus I sin theta p by q equals to cos theta by p plus I sin theta by p to the power p. Using first case, just multiplying this p cos theta p by q theta plus I sin p by q theta. But p by q means what? N. We considered here n. This is why for 3 cases we prove that cos theta plus I sin theta whole to the power n equals to cos n theta plus I sin n theta. Therefore, the de Moivre's theorem is proved for all rational values of n, including positive and negative. Okay. Now, question number 3. Application of de Moivre's theorem. If cos 2i theta equals to a plus 1 by I a, then show that 2 cos n theta equals to a to the power n plus 1 by a to the power n. We are given this condition to cos theta plus a to cos theta equals to a plus 1 by I. That means this is taking LCM a, we get only a square plus 1 divided by a. Then after cross multiplication, a square plus 1 equals to twice a cos theta. Now a square minus twice a cos theta plus 1 equals to 0. This is quadratic equation. Quadratic equation look like ax square plus bx plus c. Now we have to solve this for a. That means we have to remember that this a, we have to consider this a as x, as a variable. A is the variable here. This is quadratic in a. This is quadratic in a. We already know that x equals to minus b plus minus square root b square minus 4ac divided by twice a. This is the quadratic. For which quadratic? X square plus bx plus c equal to 0. Right? Now we are solving like this formula. A equals to minus b. Minus b means what? Minus b means what? Coefficient of this 2 cos theta. 2 cos theta plus minus square root b square means what? Minus 2 cos theta whole square minus 4a. A means what? As coefficient of a square, only 1. And c means what? Constant term, last one. Then divided by twice a. A means what? Only coefficient of a square. Understand this? Just putting x equals to minus b plus minus square root b square minus 4ac divided by twice a formula. This is the quadratic of what? X square plus bx plus c. This is the solution. Now this a equals to, we get here only 4 cos square theta minus 4. Then this then 4 if we take before this square root term, then taking common 2 to cancel, then we get only cos theta plus minus square root cos square theta minus 1. Cos square theta minus 1 means what? Minus I square minus sin square. Minus sin square equals to minus 1 equals to I square, and sin square, that means after squaring, taking a square root, then I sin theta. Cos theta plus minus I sin theta. A equals to cos theta plus I sin theta, just taking positive 1. Now taking power on both sides, a to the power n equals to what will be? Cos theta plus I sin theta whole to the power n. That means by de Moivre's theorem, what? This power will be multiplied with angle cos n theta plus I sin n theta. Equation 1. Similar case from this one, a to the power minus n, taking n minus n in replace of n. Then cos minus n theta means what? Only cos n theta. Cos can absorb negative sign. Cos n theta minus I sin n theta. This will be n theta. Here missing I sin n theta. This is equation number 2. Now adding equation 1 and 2, we get a to the power n plus 1 by a to the power n equals to this one cancel. I term cancel. Only 2 cos n theta. This is the right hand side. Clear? Now example 5. If x equals to cos pi divided by twice 2 to the power r plus I sin pi divided by 2 to the power r, then prove that x1, x2, x3 dot infinity equals to minus 1. We have to prove this. infinite terms multiplication equals to -1. Now we are given x equals to this one. That means x r equals to cos pi by twice r 2 to the power r plus I sin pi by 2 to the power r. From given x1 equals to, just putting r equals to 1, cos pi by 2 plus I sin pi by 2. And if r equals to 2, then x2 equal to what will be? Cos pi by 2 whole square plus I sin pi by 2 whole square. x3 means what? Similarly, if r equals to 3, then x3 equals to cos pi by 3 pi by 2 cube plus I sin pi by 2 cube. Then left hand side x1 x2 dot 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 infinity term. Then this one in x1 x2 x3 value dot dot infinite term, right? Now from de Moivre's theorem we know that infinite term, if we take addition of infinite term, we can write cos angle plus I sin second sin angle, right? By using de Moivre's theorem, first angle plus second angle plus third angle of cos plus dot dot plus I sin first angle plus second angle plus third angle plus dot dot for sine. Now this is the infinite series. Infinite from geometric progression. The formula is f by 1 minus r. Infinite series formula what? Sum of infinite series of geometric progression s equals to what? Formula a divided by 1 minus r. R means common ratio. A means first term. A means first term. A means first term 1 minus r. R means what? Common ratio. Common ratio, how we get? Common ratio equals to second term divided by first term. Second term divided by first term. If we divide second term by first term, we get only half. Or third term divided by second term. This is the common ratio. That means common ratio for both case half. So we get for this series, infinite series, sum of infinite series in bracket pi by 2 divided by 1 minus half plus I sin. Similar case for this same sum. Now 1 minus half what? Half only. Half cancel, only cos pi plus I sin pi. I sin pi. Cos pi means what? Do you know? -1. Cos pi means -1. Sin pi what? 0. Sin pi equals to 0. If you have to remember it. Sin cos pi equals to -1 and sin pi equals to 0. This way, this whole multiplication left hand side equals to only -1. Clear? Now question number 6, find all values of this by using de Moivre's theorem. We already know that -1 equals to cos pi plus I sin pi and pi. Cos pi means what? Cos pi means -1, but sin pi means what? 0. This is why -1 can be written as cos pi plus I sin pi. Now squaring on both sides, taking a square on both sides, -1 whole square equals to this whole square. By de Moivre's theorem, we get cos twice pi plus I sin twice pi. This also can be written as cos 2n pi plus 2 pi plus I sin 2n pi plus twice pi for n terms of angle. N equals to 0, 1, 2, 3, etc. Now -1 to the power 2 by 5 equals to what will be? We have to take 1 by 5 as power on both sides to get this. -1 2 divided by 5 equals to cos twice n pi plus 2 pi. Just this one, second bracket, power only 1 by 5. Now by using de Moivre's theorem, we can multiply the power with angle. That means twice n plus divided by 2, twice n plus 2 divided by 5 pi plus I sin twice n plus 2 divided by 5 pi. Now putting 0 n equals to 0, 1, 2, 3, 4, we get these 5 roots. How many roots here? How many values? 5 values. We have to find out these 5 values. This left for you. Only 5 values. Just putting n equals to 0, you will get first value. After putting n equals to 1, second value n equals to 2, third n equals to 3, third, fourth value and n equals to 4, fifth value we will get from this. Question number 7, solve x to the power 12 minus 1 equals to 0 and indicate if there are any relation between these roots and roots of the equation x to the power 4 plus x square plus 1 equals to 0. We have to solve this one. Now, from the given equation x to the power 12 minus 1 equals to 0, it can be written as x to the power 6 whole square minus 1 whole square. That means a square minus b square formula, a plus b, a minus b equals to 0. That first of all, we have to find out x to the power 6 equals to either this equals to 0 or this equals to 0. That means how many values here? 12 values of x. How many roots? 12 roots. Now, first for the first term, x to the power 6 equals to 1. This can be written as x equals to 1 to the power 1 by 6, taking 6th root on both sides. Now this one can be written as cos 0 plus I sin 0, right? Cos 0 means 1, sin 0 means only 0. This is why this one can be written as this. Now this cos 0 can be written as cos 2 I sin pi plus I sin 2 I sin pi by using the properties of trigonometry. Cos 2 I sin pi plus I sin 2 I sin pi, this power 1 by 6, and this power can be multiplied with this angle. How? By using de Moivre's theorem. Cos 2 I sin pi by 6 plus I sin 2 I sin by 6. Now putting n equals to 0 to 5, 0, 1, 2, 3, 4, 5, then we get 6 values of x. If x equals to 0, then only 1. If x equals to 1, then cos this plus I sin this. If x equals to 2, then cos twice pi by 3, I sin twice pi by 3. Then if x equals to 3, x equals to 4, then you will get this one, and if x equals to 5, then last one. Understand? Now for the second part, x to the power 6 plus 1, second one equals to 0. X to the power 6 minus 1 equals to, can be written as x square minus 1. That means a cube minus b cube formula. A cube minus b cube formula what? A cube minus b cube factorization formula what? A minus b into a square plus ab plus b square, right? Factorization formula, a cube minus b cube, a square a cube minus b cube formula, a minus b a square plus ab plus b square. That means x square means a and 1 means b. Then a cube minus b cube. Now for this x square minus 1, the solution will be x square minus 1 equals to x equals to square root 1. Similar, cos 0 plus I sin 0 to the power half. Then by de Moivre's theorem, we get this cos 0 can be written as cos 2 I sin pi and sin 2 I sin pi, like this. Cos 2 I sin pi plus I sin 2 I sin pi. Cos 0 can be written as cos 2 I sin pi. Sin 0 can be written as I sin 2 I sin pi. Then cos 0 plus I sin 0. This means cos 2 I sin pi by 2. Just multiplying this power by using de Moivre's theorem. You have to write in notes by using de Moivre's theorem in every case. Cos 2 I sin pi by 2 plus I sin 2 I sin pi by 2. Then these two cancel, only cos sin pi, sin and pi. Just putting n equals to 0, 1, 0 and 1. We have to find out only two roots. This is why 0 first root, and this one will give second roots. Then x equals to only plus minus 1. Now x to the power 12 minus 1 equals to 0, and this. So if the general roots are plus minus this one, because this give positive and negative also. Again, x to the power 6 plus 1 can be written as x equals to minus 1 to the power 6, right? Then cos twice n pi by 6 plus I sin 2 n pi by 6. This one minus 1 can be written as. Now if n equals to 0 to 5, then we get this one. So the roots of this equals to 0 is this. How many roots here? These 2, this 4. 2, 4 what? 6. Then how many here? They are 2 and they are also 2. That means this gives how many roots? 4 roots. And this also 4 roots. And how many plus minus 1? How many roots? 2 roots. 10 roots here. Actually there are 12 roots. If x equals to cos theta plus I sin theta and y equals to cos phi cos psi plus I sin psi and m n are positive integers, then show that this equals to this. Now left hand side, x to the power m divided by y to the power n plus y to the power n divided by x to the power m. Just putting the value of xy, we get this one. Now cos theta plus I sin theta to the power m, and this n can be written as minus n power, and similarly this m can be written as minus m power. Just multiplication. By using de Moivre's theorem, this angle will be just multiplied with angle cos m theta plus I sin m theta, and this minus n also multiplied with angle cos n psi minus I sin n psi, plus this multiplied also cos n psi plus I sin n psi, and this minus m also multiplied with this, then we get cos m theta plus I sin m theta. Now this equals to just taking multiplication, equals to cos m theta cos n psi plus I sin m theta sin n psi. Just taking multiplication, we get 8 terms. These two, and these two. How many terms? This 8. Cos m theta multiplied with this. I sin m theta multiplied with this. Then cos n psi multiplied with this plus I sin psi multiplied with this. Then we get these 8 terms. Then there is a formula cos a cos b plus sin a sin b. What? Cos a minus b formula. Then sin a cos b minus cos a sin b, sin a minus b formula. Cos a cos b plus sin a sin b, that means cos a minus b formula. Now sin a cos b minus cos a sin b, sin a minus b formula. You have to use trigonometric formula. In engineering mathematics, there are many formula for you. You can use formula on that. Make a table for formula. Now just adding this one cos m theta minus sin n minus n psi plus sin m theta minus n psi, just this 4 one. Now this one, this sign cancel. Okay, then only 2 cos m theta minus n psi. This is very easy for you. Now another application of de Moivre's theorem, solve this. We have to solve this one with the help of de Moivre's theorem. Multiplying this by this x square minus 1, then we get x square minus 1 into x4 plus x square plus 1. This equals to x to the power 6 minus 1 a cube minus b cube formula, a minus b into x square plus a plus b square. Just look like previous formula, previous example. X to the power 6 minus 1 equals to x to the power 6 equals to 1, then x equals to 6 equals to only this one can be written as cos 0 plus I sin 0, and this also can be written as cos 2i sin pi plus I sin 2i sin pi. Therefore x equals to what will be, just taking 6th root on both sides, cos 2i sin pi plus I sin 2i sin pi to the power 1 by 6. Now multiplying this power with this angle. How? By using de Moivre's theorem, we get this one. Now putting just n equals to 0 1 2 3 up to 5, we obtain x equals, if n equals to 0 then 1, if n equals to 1 then this term, if n equals to 2 then this term, if n equals to 3 minus 1, if n equals to 4 then this term, and if n equals to 5 then we get the last term, this one. Among them x equals to plus minus 1 are omitted, because for x equals to plus minus 1, n equals to plus minus 1, this is the solution cannot satisfy our given equation, this one plus minus 1. This is why we have to omit this plus minus 1. This does not satisfy our given equation, omitted. Hence the 4 roots are the rest of the 4 roots are will be accepted, and x equals to this one and minus 1 will be neglected. Why? Because these roots does not satisfy our given equation. This is why the left 4 roots are our desired result. Now similarly, example 11, solve this one with the help of de Moivre's theorem. Similar case, by multiplying x minus 1, this whole equation on both sides. On both sides, if we multiply x minus 1, then we get x to the power 7 minus 1. You have to practice it at home. Just take multiplication, then we will see that after multiplying x to the power 7 plus minus all will be omitted by cancellation. Then x to the power 7 minus 1 equals to 0, then this x equals to 1 to the power only 1 by 7. How? X to the power 7 equals to 1. This is why x equals to 1 to the power 1 by 7, taking 7th root on both sides. Now this one can be written as cos 0 plus I sin 0. Here there is a wrong. This will be cos 0 plus I sin 0. Cos 0 plus I sin 0 whole to the power 1 by 7. This is a printing mistake. Cos 0 plus I sin 0. This equals to cos 0 can be written as cos 2 I sin pi plus I sin 2 I sin pi as the previous example to the power 1 by 7. Now by applying de Moivre's theorem, we get 2 I sin pi divided by 7 plus I sin 2 I sin pi divided by 7. This is the equation 1. Now just putting n equals to 0 up to 6, we get 7 roots. How many roots here? 7 roots, because total power is 7. This is why roots will be how many? 7. And we know from earlier. Above right hand side of 1, we put n equals to 0, then x equals to 1. If n equals to 0, then x equals to 1, which are the reject to reject as we multiplied the given equation by x equals to minus 1. We have multiplied x minus 1. That means x equals to 1 will be not accepted. Hence the value of x obtained by putting n equals to 1, 2, 3, 6. That means if we n equals to 0, then we get only x equals to 1. This will be rejected. Why? Because if this x equals to 1 does not satisfy our given equation. Put x equals to 0, x equals to 1, then left hand side right hand side will be not equal. That means x equals to 1 does not satisfy our given equation. This is why x equals to 1 will be omitted for n equals to 0. So the rest one, n equals to 1, n equals to 2, n equals to 3, n equals to 4, you have to put it in equation 1. But this is left for you. You have to find out these types of solution. This left for you only. Similar example, there are 9 examples for you. Give all the roots of the following equation by de Moivre's theorem. Applying de Moivre's theorem, we can find out this and solve. You can solve these 9 equations. First equation, x to the power 5 equals to 1. That means how many roots will be here? 5 roots. 5 roots. X equals to 1 to the power 5. We can write this one taking 5th root on both sides. Then this one can be written as cos 0 plus I sin 0. Then this cos 0 can be written as 2 I sin 5 plus I sin 2 I sin 5, 1 by 5. Now putting by applying de Moivre's theorem, this power will be multiplied with this, right? Now putting n equals to 0, 1, 2, 3, 4, we get the values of x. Just putting x equals n equals to 0 here, we get first value of x, then n equals to 1, then we get value of second value of x. If n equals to 2, then we get the third value, etc. Parbe egula? Hello? Easy, very easy for you. Now x to the power 4 minus x cube plus x square minus x plus 1 equal to 0. Just multiplying x plus by x plus 1 on both sides. Then we get x to the power 5 plus 1 equals to 0 after multiplication. Practice it at home. X to the power 5 plus 1 equals to 0, then x to the power 5 equals to minus 1 only. Just minus 1 equals to cos pi plus I sin pi. We have already solved it. Look like this example. Just putting x equals to 0 to up to 4. Then we get in right hand side, then we get the values of our roots. Now x to the power 7 plus x to the power 4 plus x cube plus 1 equals to 0. How we can solve it? Just making it factors. Take common x to the power 4, then x cube plus 1, and here 1, then x cube plus 1 into x to the power 4 plus 1. Either this equals to 0 or this equals to 0. From first one, x to the power 4 equals to minus 1. This minus 1 can be written as this one. Then we get these 4 roots. From again second one, x cube plus 1 equals to 0, x cube equals to minus 1. This is why similar case, just putting x equals to n equals to 0 to 2, 3, 1. Now we get the required roots. Similar process, just factorization process, then give 2 term equal to 0, then first 1 equals to 1. Just practice it at home. This one. This also you can do x plus 1 to the power 5 plus x to the minus 1 to the power 5 equals to 0. Now just dividing both sides by x to the x minus 1 whole to the power 5. Then you get this one minus 1. This minus 1 means 1 by 5. This one what? Cos pi plus I sin pi. Now this can be written as cos twice n plus 1 pi plus I sin twice n plus 1 pi from trigonometric properties of solution. This x plus 1 divided by x minus 1. This equals to just putting 1 by 5 multiplied with the angle by using de Moivre's theorem. Now component to divide and do. Component to divide and do in Bangla, Zuzon Buzon. Numerator plus denominator in up. Numerator minus denominator in down. Similar case in right hand side, numerator plus denominator, and in down numerator minus denominator. Now after cutting, this 1 cancel, x cancel in down, then 2 divided by 2, only x1, x equals to this one. Now putting n equals to 0 to 4. How many roots will be here? 5 roots of x. This 5 why? Maximum power of x term is 5. Maximum power will be what? 5. This is why we have to find out 5 values of x. Similar case, there are maximum power x, how many? 4. This is why this equation has 4 roots. Similar, we have to proceed similar process. Then putting n equals to how many? 0 to 4. Only if we take n equals to 0 here, 0, this will be satisfied. 0 and 0, if we x n equals to 0 will give, what's the value here? Cos n equals to 0, cos pi by 4. Cos pi by 4 means what? 45 degree. Then sin 45 degree. Then this one, n equals to 0 means cos 45 degree, I sin 45 degree. That means this one cancel. The x equals to what will be? Only 1. X equals to what will be? 1. X equals to this 45 degree, 45 cos 45 degree 1 by root 2. This also 1 by root 2, and this one 1 by root 2, 1 by root 2. But there is a 1. So 1 twice root 2 plus 1. That means non-negative. You have to satisfied with test the verification for a given equation. Now similar process. How many roots will be here? N times roots, because maximum power is n. You have to use r here because n is already given. This is why we have to introduce another constant r to suppose cos 0 equals to 2 cos 2 n phi, not but 2 r phi, because n is given in equation. This is why you have to use r here, 2 r phi and I sin 2 r phi. Just multiplying 1 by this power with the help of de Moivre's theorem, then we get this one. This x minus 1, x divided by x minus x plus 1 equals to this one. Just taking only component do in denominator. Now putting n equals to 0, 1, 2 up to n minus 1. Up to n minus 1. Then we get n terms of x. Similar process, factorization. After factorization process, just taking common x5 and here only 1. Then we get x4 plus 1, x to the power 5 minus 1. Either this equals to 0 or this equals to 0. So how many roots will be? 9 roots, because maximum power is 9. From first one, x4 plus 1 equals to 0, then x equals to minus 1 to the power 4. That taking fourth root on both sides of this equation. Now this minus 1 can be written as a cos pi plus I sin pi. Then by de Moivre's theorem, similar, just n equals to 0, 1, 2, 3. This will give 4 roots. Now x5 minus 1 equals to 0. X to the power 5 equals to 1 can be written as this. This 1 can be written cos 0 I sin 0. This means cos 2 I sin pi, sin and 2 I sin pi. 1 by 5 multiplication with angle by using de Moivre's theorem. Now n equals to how many values? 5 values, because power is 5. 0, 1, 2, 3, 4 will give the 5 roots for this equation total, and 4 roots for this equation. Then we get 9 roots. This is the total result. Second, another example 23. If xr equals to cos ar by br pi plus I sin ar by br pi, then show that x1, x2, x3 dot dot infinity equals to cos pi a divided by b minus a plus I sin pi a divided by b minus a. Now given that x r equals to this one, this is given condition. Now putting r equals to 0, 1, 2, 3 up to infinity, we get x1 equals to this, x2 equals to this, and x3 equal to this dot dot. There are infinite numbers of x. Now taking multiplication x1, x2, x3 dot dot up to infinity, we get this x1, this x2, and this x3 dot dot up to infinity. Now as like the previous example, we have solved like this example. Now just cos this, cos this, cos this, cos angle plus first angle, second angle, third angle plus dot dot for cos, plus I sin first angle plus second angle plus third angle plus dot dot up to infinity for sine angle only. Then here this term, this is the geometric progression of infinite series. This is the infinite series, but geometric progression. This result will be what? First term divided by 1 minus common ratio. Common ratio how we'll find? Second term divided by first term. It will give common ratio, or third term divided by second term will give the common ratio. Common ratio will be, if we divide second term with first term, then we get a by b only. This is why first term divided by 1 minus r. R means common ratio. Plus I sin, similar case as for sine term. Now this one after multiplication and division, then we get this one. This is the right hand side for you. Very easy for you. This is the interesting example. Now example 26. If x equals to cos theta plus I sin theta and 1 plus square root 1 minus a square equals to na, then show that this equals to this. Then means 1 plus a cos theta equals to a divided by twice n into 1 plus nx bracket and another bracket 1 plus n by x. We have to prove this condition. Now we are given x equals to cos theta plus I sin theta. Now 1 by x equals to what will be? 1 divided by this one. 1 divided by this one means what? Cos theta plus I sin theta whole to the power minus 1. But this minus 1, using de Moivre's theorem, you can write one. How many? Cos minus theta plus I sin minus theta. I sin minus theta equals to what? Minus 1. This way cos 1 by x can be written as cos theta minus I sin theta. Now just adding this one, x plus 1 by x equals to what? Cos I sin theta will be cancelled after addition. 2 cos theta will be give the result. Now equation 1, this to make it equation 1. Now another condition I are given, 1 plus square root 1 minus a square equals to na. Now square root 1 minus a square equal to na minus 1. Squaring on both sides, 1 minus a square equal to na minus 1 whole square. A minus b whole square formula. Now 1 minus a square equal to a square minus twice ab plus b square formula. This equals to twice n divided by a equals to n square plus 1. This is the second equation. We have to use this equation 1 and 2 in right hand side. Now right hand side we are given a by twice n, 1 plus nx, 1 plus n by x. Now a by twice n equals to only 1 nx, just multiply these two term. 1 multiplied with this, we get this one, and nx multiplied this with it. Now taking, just arranging the term n square plus 1, then this nx plus n by x will give common n bracket x plus 1 by x. X plus 1 by x equals to what? Given x plus 1 by x equals to 2 cos theta from equation 1. Now n square plus 1 what? From equation 2, twice n divided by a. And this wholly gives the left hand side. 1 plus a cos theta. 1 plus a cos theta. Multiplying by a by twice n in both term, then we get 1 plus a cos theta. This is the left hand side. Similar, example 27, this is left for you by using de Moivre's theorem. You can solve this. There will be 5 roots. And prove that the sum of n power of the roots of the equation an integer not divisible by 5 is 0. You have to prove another condition.
After solving, we get these 5 roots for r equals to 0, 1, 2, 3, 4, etc. We will get 5 roots, this one. Now for second condition, sum of n power of the roots, that means 1 plus first term, second term, third term, plus fourth term, plus up to dot dot, equals to 0, which is 0 and not divisible by 5. It cannot be divisible by 5. You have to prove this is the second term. Now example 28. Prove that the general value theta of theta which satisfies the equation up to n terms. This first term, second term, plus dot dot, n term equals to 1 is this. You have to prove. Now we are given cos theta plus I sin theta into cos 2s theta plus I sin 2s theta dot dot cos n theta plus I sin theta equals to 1. That means by using de Moivre's theorem, this whole multiplication, just angle will be added. Cos angle will be added for cos, plus I sin angle will be added for sin. By using de Moivre's theorem, we get this. How many theta will be here? This equals to, this one can be written as cos 0 plus I sin 0 degree. That means cos 0 degree plus I sin 0 degree. Now we can write cos theta plus twice theta plus n theta. This equals to cos twice k pi plus I sin twice k pi. Because in left hand side n is already given. This is why you have to introduce another constant k. Cos twice k for right hand side. Cos twice k plus I sin twice k. Now equating the real and imaginary part on both sides. Cos term left hand side, in left hand side cos term is this, and in right hand side cos term is this. This equating cos this one is which kind of series? Arithmetic series. Arithmetic series. This will be 1 plus 2 plus 3 plus dot dot n. This will be the sum of this. What will be? Sum of n terms and number of terms. Sum of natural numbers. Sum of n number of natural numbers. This will give n into n plus 1 by 2 equals to cos twice k pi. This cos cancelled from both sides. Now this angle equals to this angle, then theta equals to this, which is our required result. Very interesting and easy for you, I hope. This is left for you, 29, just left hand side equals to right hand side. This is also for you, left. This one also, this is given, and we have to show this condition. We are given sine inverse. We know sine inverse A equals to tan inverse A divided by 1 square root of 1 minus A square. This is from inverse trigonometric function. Inverse trigonometric function. Sine inverse alpha equals to tan inverse alpha divided by square root 1 minus alpha square. And we are given tan inverse A plus IB equals to sine inverse this one x plus IY. But this sine inverse can be converted into tan inverse by how? Tan inverse x plus x divided by 1 minus x square, like this formula. That is tan inverse cancel. A plus IB equals to this, equation number 1. Similarly, conjugate complex number A plus IB equals to this. Then conjugate complex number, what will be? A minus IB. This equals to just conjugate complex number will be used in right hand side. Just in replace of plus, we have to use only negative sign. Just before I terms, remember it, not in middle. Multiplying 1 and 2, we are given a square plus b square equals to this one, just multiplication. Multiply I square equals to minus 1 used here, proved. Similarly, left for you, this is very easy and very little example for you. Example 33 also you can. Example 34, a little bit hard, seems to be hard for you. Now can be seen, not maybe. Okay. In this example, given condition is if I to the power up to infinity power. That means every I is power to previous I. I to the power dot dot infinity equals to A plus IB, capital A plus capital B. Then we have to show that tan pi a by 2 equals to b by a, and a square plus b square equals to e to the power minus pi b, capital B of course. Now we are given I to the power equals to a plus ib, and we know that I equals to e to the power I pi by 2. E to the power I pi by 2 can be written as I. Now taking a plus ib power, a plus ib. Now I to the power a plus ib, right? Whole this I to the power infinity goes to a plus ib. This why this can be written as I to the power a plus ib equals to a plus ib. Now this a plus ib can be written as I to the power a plus ib. Now this equals to e to the power by using this formula. I equals to this one e to the power I pi by 2 formula. Now a plus ib equals to e to the power I pi a plus ib. This equals to e to the power, just multiplying I pi on both term, I pi a plus I pi b. Next, a plus ib equals to e to the power minus b pi by 2 into just factoring the power of e. A plus ib equals to e to the power minus pi b pi by 2 and I pi by 2. A plus ib equals to e to the power minus pi b by 2, and this I pi by a by 2 can be written as cos a plus I sin cos theta plus I sin theta, e to the power I theta formula. Cos theta plus I sin theta, e to the power I theta. Now equating real and imaginary part on both sides, a equals to can be written as this power and this cos term, and b equals to can be written as sin term in this one, equation 1 and 2. Now dividing equation 1 and 2, we get this 10 pi a divided by 2 equals to b by a, and squaring, then adding, we get a square plus b square, this one. Just do practice at home. I hope you can do this one, you can solve. And okay, next day in next class we will solve the rest one.